my AP Calculus, it's Miss Deer. I just wanted to go over the problems that you did, especially number one, because it's actually a little bit trickier than it looks. So for this one, when we sketch the region, we can see we have x equals 0, y equals 0, and x cubed plus 2, in addition to x equals 3 over here. So the easiest part of this is just to set up to find the area in terms of x. On top is always x cubed plus 2. On bottom is always y equals 0. So my area in terms of x is the integral from 0 to 3 of x cubed plus 2 dx. To evaluate this, we take the antiderivative from 0 to 3. 3, 9, 27, 81 over 4 plus 6. It's a lovely number. 81 over 4 plus 6. Alright, oh, there's my dog. Alright, so for part B, to find the area in terms of y, remember when we do in terms of y, we do right minus left. What's interesting about this region is that on the right hand side, on the bottom here, up until y equals 2, we have this on the right and this on the left. And then from 2 to up here, we have the point 3, 29. So from y equals 2 to y equals 29, we have x equals 3 on the right, but the curve on the left. So for this part down here, we could definitely use calculus, or we could just use the fact that this is a rectangle that's 3 wide and 2 tall, so my area is 6. Plus, now for this top region, I have to do right minus left. So if y equals x cubed plus 2, x equals the cube root of y minus 2. That is this curve right here. So to find my area, I'm going to take the integral. Remember, my y values go from 2 up to 29. Of right, on the right side of this region is always x equals 3 minus left, which is our curve y minus 2. I can't evaluate that in my brain, but you guys can do that on your calculator and make sure you get this lovely number over here. So to rotate this around y equals 0, again, we're going to look at our region, and this is actually the easiest one. So to rotate this around y equals 0, I can see that this piece is going to come down here and like this. So all my cross sections are going to be circles. So my volume is going to be pi r squared. If I'm rotating around y equals 0, they're getting stacked this way. So that's in the x direction. My x values go from 0 to 3. And then remember that my radius is always measured from the axis of rotation. So my radius is going to go from 0 up to my curve. So my radius is just going to be x cubed plus 2 squared. So the hardest question on here is actually the last one. Where we revolve it around the line x equals 3, because just like we had to divide the area into 2 pieces, we have to divide the volume into 2 pieces, because for this bottom piece, these are all going to rotate this way, and we're going to have a nice solid base. So for the bottom part to rotate, my volume will be the integral. My y values go from 0 to 2 of pi r squared in the y direction. Again, because I'm rotating around the line x equals 3, my radius is going to extend from 3 to the edge, so my radius is constantly 3. Now to this, I have to add this top piece, which is going to rotate this way, make this a very cool shape. So here, my y values are going to go from 2 to 29. Again, each cross section is a circle, so it's pi r squared. Now, my radius, because it goes around from the axis of rotation to my curve, my radius is this piece right here. So it's not the cube root of y minus 2, which is here, it's 3 minus the cube root of y minus 2. And this whole thing is my radius.